Some more with exponential functions here. We got 3.7 parentheses 2 being raised to the x power, and it wants to know growth or decay. So we can look right here. We have b is greater than 1, that's growth. B is less than 1, decay. And there's that formula too, y equals a times b raised to the x again. So b is greater than 1 here, so that's growth. The factor is just simply b. So that's going to be 2. And then the initial value is always going to be the thing that's not being raised to x, or it's going to be the thing that's kind of in front of the parentheses. So it's 3.7. Okay, another really important thing about A is what y is when x equals 0. Huge concept for this. Okay, and I hate that there's two is verbs in here, but you know, A is what y is when x is 0.
So what does that mean? What I'm saying is x is 0, y is 3.7.
So see how that is our y when x is 0.
And it's always like that in this exponential form.
To create a table of values, you really need a calculator. I would just start plugging in additional x values after 0. So 1, 2, 3, and 4. All right, a little refresher on how to put these in here. You're gonna do, well, we gotta start it up first. Let's see, my equations, y equals 3.7 times 2 being raised to the x power. So I'm gonna put in 3.7 parentheses 2 raised to, and that's raised to whatever x we're using. Whatever x we use gives us that y. All right, so I would put it in like this, 3.7 times 2 raised to the first power. You just simply record it. And another thing about this calculator here, you could put in, I don't think I've showed you guys this yet, but you could hit second, enter, and it brings up whatever you just did, basically. Whatever you just put in to get that answer, it'll bring that back up. And then you can go and edit it. So we could change that 1 to 2. A little bit quicker. And that gives us the y when x is 2.
You guys see that? Okay, so you go ahead and finish that table out yourself, of course if you have a calculator, and I'll be working on it as well. All right, yours look like mine here. You go 7.4, 14.8, 29.6, 59.2.
If it does, very good job.
Okay, growth or decay, we could wait a little bit until we write the equation, because we're gonna have to anyways, or we could just look at the table. All right, so I'll show you how to do that. Growth occurs, growth is like when we learned linear, so remember these linear models? Growth is like increasing. You don't have to write this, I'm just kind of showing you a picture. It's like increasing, meaning as x goes up, y goes up. Okay, so that means what? Well, decay would be the other way. Decay would be as x goes up, y goes down. Increasing again would look like this in a linear model. For growth, it's going to look like this. Decay would look like that. And for linear, it would look like this.
The cool thing about these, there's some similarities. You would be sliding down both of them if it were very icy, or if you were on a roller coaster. That would be the fun part. That's a way to think about it. Decay and decreasing, all that good stuff, it would be the fun part of a roller coaster. So, woo, when you see that. All right, so is the function exponential? Yes, there's a factor going on. We're gonna figure it out here in a second. Is it growth or decay? Well, y is going down as x is going up. So as x is going up, y is going down. Either of these look like that? Oh, there we go. So decay. All right, now let's find that factor. So the factor is simply found by dividing, dividing 1y by the previous term, the previous y before it. So this 27 divided by 81. And that's going to give us, what is that? 0.33333. So we could convert that to a fraction, hit math, hit enter, 1/3, looks good. Factor is 1/3. Initial value occurs somewhere in here. On some of these, you have to work the table up to an x of this specific number, but here we already have it because when x is 0, we have our a. So when x is 0, we have a. Always, just always works out that way. So it's right here, but we don't write 0. We're gonna write what y is when x is 0. Okay, so what does all this mean? Well, it means we can write an exponential equation. The form of that exponential looks like this again. So that's a times b raised to the x. And now we can start plugging this stuff in. So I know I have a b, so that would be y equals a times 1/3 raised to x. And I have an a. So I'm gonna go and write that one in the next step. Y equals 81 times 1/3 raised to the x power. When x is 0, we have a. So this thing, I would make this note as many times as you need to. Okay, so when x is 0, this is y. Kind of looks funny, but you know, basically what I'm saying is we need an x of 0 to find a, all right? And if you look closely, we do not have an x of 0 here. We have in all the other problems so far, but we don't here. So what do? Can we even do this problem? Well, there's definitely a way. There's a strategy, all right? And I know it gets a little confusing sometimes, but what I've told my students to do with this is just basically start with this and divide them the way you see them. So that's one of these rates. So 13.2 division bar 29.04. In the calculator, that's 0.45 repeating. Okay, and while I'm doing this is either going to be the up or the down motion, or the up or the down direction, if you will, of our table. So as we go down, this is our rate, or as we go up, this is our rate for y. I know it's not the rate for x because x is increasing by 1s. All right, and now what we're going to do is just flip it. So 29.04 divided by 13.2. So 2.2 is that other thing that's going on. So believe it or not, both of these rates are going on. Both of these rates are occurring. If you don't believe me, you can multiply this 309 right here. 309.22 times 0.45. Okay, so pretty close there, 140. And now let's just do it the other way, 29.04 times 2.2. Boom. All right, so just proved it. But what does this mean? Well, we have to work up to get an x of 0. I know that. But it's a little tough trying to figure out what rate to use and what to multiply to what. So what I told my students to do is look at these two rates here. You have two directions they could be. One is up or down, the other is the other one, okay? So look at that y. Could we multiply that by 0.45 to get a 29.04? I don't think so. I mean, that would be not only smaller than 13.2, but it would not be anywhere close to this. So that's not our downward direction. And then 13.2 times 2.2, well, that's a little bit better. I think that would be our downward direction. So we like to cross that one, that one that it's not out. So that means that this is the way we go up for y. Meaning we can multiply this 13.2 here by this and get this y, which is what we have to do. So 13.2 times 0.45, repeating as much as I can there, get it as accurate as I can. Wow, even 6. Look at that. So 6 is what? What is 6? Well, 6 is what y is when x is 0. We had to work this table up to an x of 0, and 6 is the y that occurs when x is 0. And 6 is also something else. 6 is our a. All right, so what's our factor then? Well, the factor, or b, is simply which of these rates, or which of these are occurring as x increases. So which of these is occurring as x increases? And that's, again, we've already covered it, but definitely the bigger one. It's the only one that could be going on. So it's 2.2. Means we can now look at this. It is exponential. It is growth, because that's greater than 1. The equation would look like this. And now we just have to plug stuff in. So 6 there, 2.2 there, and you're done. You could write it like this as well, so same thing. Very good. You go ahead and try number 3, especially if you weren't here. I would want you to try this and bring it back whenever you can, and I'll look over it, all right? For this one, I'm gonna do on the video. It says, given the following data from a largemouth bass population in a local pond below, find the exponential equation that models this situation. It says to let 0 represent, this one's 0, this one's 1, this one's 2, and this one's not too bad because they're all right there, but 3, 4, 5, see what they're doing there? You can't start with an X of 1972 or whatever. That'll mess the problem up because they give you this really important bit of information. You have to let 0 represent that year, okay? So this isn't 0, that's not that year. 1972, that's not 0, so that's 2. All right, so you gotta work up. And we're gonna have to anyways because that's where A is. So 200 divided by 322, that is one of our rates, of course. That's how we go up, 0.62, I already know. But 322 divided by 200 is how we go down, 1.61. So I'm just gonna mark that upward motion out, and this is how we go up, because 0.62, if you think about it, multiplying this times something above 1 would be not only above 322, because anything times 1 would be itself, but it would also be getting close to double that number. So 0.62 would be getting close to halving that number. So it makes sense that that's what we're doing when we're going up, okay? So what do I mean by that? Okay, we gotta multiply 200 by that to get the y above it. Okay, so I just did that. I put in 200 times the rate that it appears the pattern shows us. If you multiply a y by this 0.62, it gives you the y above it. So that's why I'm doing this. It gives us 124 when x is 1. So that means we have to work up one more time. So 124 times 0.62. And that gives you 76.88. Okay? So now what do? Well, this y when x is 0 is a. So we're gonna plug it into the formula. It's gonna be y equals 76.88 times b raised to the x. And I've already said b is what's happening to y as x increases by 1, okay? So that looks like this one. And that's your final answer there.